Hi, everybody. I'm going to talk about Newman projections in this video. So Newman projections are going to help us visualize molecules in 3D because we've been talking about a lot of sp3 structures that have that tetrahedral geometry to them. And that has a really special situation of giving us a lot of 3D nature in our molecules. So before we get going on that, we kind of need to know a little bit about how to draw 3D, how we do it besides Newman projections. One way is to use the wedge and dash system. So they are shown right here. The wedge is going to be coming out of the paper towards your face. Okay, so if I have this molecule, this would be a wedge according to your perspective. Okay, the dash is going to be going away from you, and that's going to be the blue one, and that's the one in here in the back, and that's going to be going away from you. Okay, the straight line, which is what we've normally been using, is going to be anything that is in the plane of the paper. So in this case, my white and then the one that doesn't have any sphere on it, those two pieces are my in the plane, and then wedge and dash from the camera's perspective, from your perspective. Okay, so a Newman projection, we've typically been looking at molecules. Stop the share real quick. We typically look at molecules like this, right? So we kind of have our zigzag would be right here. And then we have, this would be a wedge. This one would be a dash going away from you. This would be a wedge. This would be a dash going away from you. So this is kind of how we've been drawing them. A Newman projection is really asking us to change our perspective here to be from this, like we normally see it, to looking down the carbon-carbon bond like this. Okay, so basically, if we look at what we've got here, let me pull it farther in. So at the front, we have a carbon that has three things coming off of it. And on the back, we've got a carbon that has three things coming off of it. Okay, and together you kind of have the two carbons. One is in the front, one is in the back. The back one is completely overshadowed by the one in the front, or eclipsed. And then we can kind of see what the relationship between our different substituents are. Okay, so this allows us to help kind of identify lower and higher energy conformations within a molecule. So this is what we're going to practice doing. Okay, so in Newman projection, you focus on drawing front carbon stuff and then back carbon stuff. And the way that we do that is through a fancy little diagram. Okay, so let me share again. All right, so if we're looking at a Newman projection, this is going to be kind of what they look like. So just as I had in our little model here, this is the representation of that front carbon. And then our circle, you can basically think about that as being my hand that was kind of blocking the back carbon stuff. Okay, so it's just helping you to focus on what's on that front carbon. So in this case, A, B, and C are all on that front carbon. Okay, the things on our back carbon, I've labeled X, Y, and Z, and those are going to be coming out of the edge of a circle. Okay, so notice that they don't go into the middle. They stop on the outside and stay on the edge versus coming from the middle. Okay, that's going to be really important. So these are the ones on the front, and then X, Y, Z on the back. Okay, so making sure that we're not putting everything on that front carbon is really important here. And then we've got the two carbons, one is there, and then the second carbon is just right behind that dot. Okay, so we have two forms that we can kind of think about. These can be staggered, which is what we have here. Let me get it lined up. So you see 6 very distinct substituents off of these 2 carbon atoms, and that is the staggered form. Okay, if you rotate this, and you can rotate the front or the back carbon, it doesn't matter which one. So once you have it here, if you're eclipsing all of them, now it looks like I only have 3, but I still have all the same ones. And so because it's really hard to draw things completely overlapping each other, stop the show real fast, we're going to have to go back and forth a few times. Okay, so instead of drawing it like this, we're just going to very slightly off center it, and we're basically drawing this perspective drawing. okay? But drawing it on a 2D piece of paper. So this is where organic chemistry becomes drawing class for sure. But I like drawing, so it's all good. Okay, so that's gonna be our eclipse version, where we're gonna have those lines kind of right next to each other, but not overlapping, because then we can still see everything and nice and neat. Okay, and this is gonna be our eclipsed. All right, so every time you're drawing this, you should have 3 things on the front and 3 things on the back if both of your carbons are sp3 hybridized, okay? So this means drawing in your H's. And this is a part that a lot of people try to skip it, and then they have Newman projections that just don't look right. And that's because you should always be keeping that kind of 3 pieces of a pie in your head the whole time. Okay, so let's look at ethane first. Okay, so because we have to think about how do we get from this kind of drawing, I'm just going to move this one down for now. How do we get this drawing into a Newman projection? Okay, so what I think the easiest thing to do is to build a model. One, we're going to use models, and we're also going to think about kind of doing it in our heads as well. But I think easiest is to build a model. But basically what we're doing here is we're thinking about putting our eye in the perspective of the screen or the page, okay, and basically saying, okay, what's showing up on my left, what's showing up on my right, and then what's going up and what's going down. Okay, so if I was just looking at this one on the screen, I would see, if I was a little person right there, I would see an H going straight up, and then an H going to, that wedge one is going to be going to my right because it's coming out of the screen, and then my dash one is going to be going to the left. Okay, and if we look at the model of this, we can basically, let me get this set up again here. Okay. So we can basically look at that front carbon as H straight up and then left and right. Okay. So we're going to draw our Newman projection. We start off with drawing a circle. And then I've got H coming, H coming straight up, label that H, and then H to the left and H to the right. So that's our front carbon. And then if we keep looking along this bond to our back carbon, we have an H that's coming straight down. So that I always think that for straight lines, if they're just kind of on the zigzag, they're going to be up or down. That's the easiest way for me to think about it. So I have an H here, here, and here. This is going to be a lot more interesting once we actually have things other than H's on it, though, I promise. Okay, so this is our staggered form. Okay, that's going to be our most stable conformation. And then the cool thing about Newman projections is that you can just rotate them. And I'm going to just give us a few little numbers here. Just so that we can see a change because we've got a bunch of H's here. So you can rotate the front or the back. It doesn't really matter which one. So I'm going to rotate the back one. So I'm going to keep my front carbon exactly the same. So I still have 1, 2, 3 going clockwise. And then I can rotate this so that it's HA, HB, and HC. A, B, C. Okay, so I just have scooted it all around, and that's just your physical rotation around that central atom, where you're just lining all those up into that eclipsed, there we go, into that eclipsed conformation. Okay, so we're no longer here. There we go with the 6. We are here with the 3 and the eclipse. Okay, so this is going to be our eclipsed. this is going to be your least stable conformation. Okay, and this is due to the torsional strain. That the molecule feels when it's in that particular conformation. So torsional strain is just the bonding electrons getting too close together. Okay, so if we look at this eclipsed form, so we've been looking at it this way, but if we look at it more typically in our normal fashion, we see that we kind of have a U shape of in the plane bonds. Okay, and that's kind of the problem, is that we've got bond here, and they're just a little too close together because they're not just sticks like this is, right? They have kind of a cloud space. So if we look at what this would look like on the flat, we would have two H's in the plane. And we're going to have a wedge H up there, a dash one there, a wedge one here, and a dash one. Okay, so we're actually seeing that both of these H's, well, all three of them, are going to be overlapping each other, because our two wedges are right there, our two dashes are right there, and our two straights are right there. Okay, so that's kind of what that looks like. So let's look at an example where we have something that's a little bit different. And I'm going to work on this really hard, because this is the hard part for me, because I'm doing it basically in a mirror with the camera. So I'm going to do it all from the perspective of you as the viewer and not as me, because it's all backwards for me. So I'm going to probably choose my words very carefully and go a little bit slower. So in this one, I've got X is going to equal blue and Y is going to equal red. I'm going to make that note for myself just so that I make sure that I don't mess it up. Okay, and we're going to look from a different perspective this time. We're going to look right down this bond. Okay, just to show you that you definitely can look different directions, but typically you're going to want to look for which ones have, stereochemistry associated with them, and look down that bond. And I will tell you which bond to look down when I'm asking you to do a Newman projection. Okay, so once we're here, we're looking down this guy. I'm gonna go ahead and stop the share real fast. Okay, so we're looking, this is my front carbon. Okay, so I've got my CH3 going up. I've got this part with my ethyl group going back. Okay, these two carbons are the middle part of my Newman projection. So on here, I've got my red one going to the right, my blue one going to the left. So let's go ahead and take a look at what that's going to look like in our Newman projection. And I would say most of the time, if you're going to do this yourself, like obviously don't set it up like I'm doing it. You're going to have it actually facing you so that you can just draw what you see. This is definitely the hard version, just because I'm trying to do it from your perspective as a viewer and make sure that it makes sense. Okay, so we're just going to start with our circle. And I've got the CH3 going up. And then we look at our front carbon, we've got that red on the right. That's our Y. And then our H on the left. Okay. Whenever I'm doing this, it does help to draw in those hydrogens on their respective wedge dash, just so that you have them there. Okay. So again, if we were kind of thinking about being in the screen here, our Y is going to be pointing to the back. So that's going to be on the right-hand side for us. And then if we continue looking this way, our X is going to be on the left. Okay, so we're going to have X completely opposite of Y, and then H, and then down here I just have an ethyl group. Okay, so that I don't really care what it looks like. It could be pointing a number of ways. We just need to make sure that we have all the right carbons. So if you're counting this, you'd go 1, 2, 3, 4, 5. Okay, because we've got the 2 carbons in the back there. Oh, two carbons over each other. Okay, so this one is a staggered form, specifically anti, okay, or anti, whatever you want to say. And that's just due to the 180-degree bond angle here between your largest substituents. Okay, so that's going to be our most stable. When your two largest substituents are 180 degrees. Okay, and that would be considered the anti-conformation. Okay, so if we again go back to looking at it flat, okay, that's kind of what we're looking at. So if I want to rotate this, okay, so if I'm here and then I rotate it, I usually tend to rotate the side that has fewer carbons, but you can rotate either side. I just find it easier to not have to deal with multiple, just works better in my head. So I'm going to rotate this carbon and we're going to rotate it 180 degrees. And keep in mind, there's definitely different conformations you could go here. You could say that's a different conformation. That's a different conformation. And these are all going to have different energy levels associated with them. But we're going to go to this one. Okay, so I can have kind of my front, my back. We can see that I've kind of got some eclipse happening here. So that's going to look like this in the Newman projection. Okay, so if we rotate around that, actually. Okay, so I've got my circle. I have rotated my front carbon, so now my CH3 is going straight down. So, and I have my red Y, Y is red, going off to the left, and H going off to the right. And I have not moved my back carbon, so all of this is going to stay the same. So I still have X there, still have H there, and I still have an ethyl group there. Okay, so this would be our eclipsed conformation. And at that stage, if we look at what that would look like in flat, we can rotate back to here. And you can see that we've got, it's different. We've got that kind of U shape. Okay, that's going to be very typical of any kind of eclipse conformation, is this U shape here. And then you can see that we have both the red and the blue now facing towards you as wedges. Okay, so we want to make sure that we get our carbon skeleton to be in the right shape, and then our wedges and dashes correct. So when we draw that, we're going to have our backbone kind of like this. And keep in mind, look how this did not change. That is still all the same. So I still have an X on a wedge, but now my Y is also on a wedge. Okay, because we just rotated around that bond and pulled this guy down, which pops our Y out to the front. Okay, this becomes a whole lot easier once you work with models for a long time. So definitely take some time to practice, see what happens when you kind of rotate them, when you flip them, all that stuff. Okay, so we're going to practice this in class. And as always, let me know if you have any questions, and I'll see you all later.